Okay, so this unit now we're actually starting in on the trig functions. We've done all the circles, all the geometry, all the basics we need to build up to it. So it's time to start cranking them out. And as I mentioned before, trig does not come from triangles. It's applied to triangles. Trig comes from circles. And more specifically, something called a unit circle. Now let's review a little bit before we jump into the details of that unit circle. Pretend that looks like a circle. Remember, there was something we called a reference diameter, and that is a horizontal diameter. We talked about this unit circle a little bit when we were dealing with converting angles to radians and stuff like that as well. But anyway, there are tangents. What does a tangent do? Touches the circle, but never enters into the circle, never penetrates the circle. So yes, it does touch the circle at exactly one point. And then there is a secant. What's the definition of a secant? Yeah, the technical definition of a secant is it is a segment or a line that contains points that are both inside and outside of the circle. And then there is something called a sine. A sine is a quality of each point on the circle. And it's related to that reference diameter. So let's say I pick that point. The sine of that point is the distance to that reference diameter. That is the sine of that point. If I pick this point, that is the sine of that point. If I pick this point, there's the sine of that point. Now this point here has the same sign as this one did over here, because they're both the same distance above that reference diameter. So that's sine, secant, and tangent. Well, why did I make a point of going over those geometric features again? Pretend that looks like a circle. There's that horizontal reference diameter. I'm going to put it in a vertical diameter just to reference off of. But this is 0 degrees here. This, of course, is 90 degrees, 180, 270, and then back to 360 would be back to 0. 0 is what we call the initial side. Of an angle. So all angles start out here. And they go, as you can see by the way we've got it labeled, counterclockwise. So that's 40 degrees or whatever. I'm going to call that angle theta. That's the Greek letter theta, looks like that. It's what we use to represent a generic angle. You know, it's just like x, y, or whatever. It's just a variable for an unknown angle. That purple line is called the terminal side. So initial side is where the angle begins, terminal side is where it ends. And that terminal side of an angle defines a point on our circle, right there. That red dot is the point that it defines on the circle. That is the point that is that many degrees along the arc. Remember, we just talked about arcs. Away from 0, or the initial side. Well, the sine of that point is defined to be the sine of that angle. That's the sine of theta. Now, of course, a tangent touches the circle, and it's tangent to the circle at this initial side here. How do we know where to end it? Well, we end it where it intersects that line. So the tangent starts at the point of tangency and goes up toward it intersects that terminal side if we extend it. The length of that is the tangent of that angle. This piece here that we extended out to meet the tangent contains points that are both inside the circle and outside the circle, so that is the secant of that angle. Those are the three main trig functions: sine, secant, and tangent. Now you might be thinking, those aren't the three I was taught. What were the three that most of you were taught? Sine, cosine, and tangent. What is a cosine? Let's talk about that for a minute. Well, if you look at the word cosine, you see very clearly the word sine. Co is a prefix. You've got possible, impossible, prefixes that change the meaning of the word. Cosine means, means of the complement. So cosine means the sine of the complement. Now looking at this, the complement of the angle theta actually does appear in this drawing. Because this is a 90-degree angle here, right? This angle right here would be the complement of theta. Does that make sense? So its sine would just be the distance. I'm going to use reddish. The distance from here to here. When we do the cosine, the complement means we're going to use this as our reference axis. The vertical axis is our reference axis. So that would be the cosine. Now that distance, since this is a right angle and this is a right angle, makes this thing a rectangle, right? This is a right angle. We have three angles are right. The fourth one has to be right. So that length up there has to be the same as this length down here. So that length is the cosine of that angle. And of course we could extend this out and we could put in the tangent up here. This light brown line would be the cotangent of that angle. This purplish line would be the cosecant of that angle. Make sense? But for our purposes, the ones that we're going to use most, we're going to talk about the secant, cotangent, and cosecant. But of course, we're going to use cosine, sine, and tangent because those are the buttons that appear on your calculator. The sine and the cosine can be thought of as coordinates. Because if this center of this circle is 0, 0 on our graph, right there, the x value of that point on the circle is the value of the cosine. The y value of that point on the circle is the value of the sine. Okay, now let's do some useful stuff here to get this now related to triangles. How do we get this related to triangles? I'm going to start out with this triangle right here. I'm going to pull it down here. Oops, come on. You know you want to. I'll put it right there. I'm going to fill in the this is the angle theta. This side was the sine of theta. This was the cosine down here, right? What was this side right here?
Secant.
The secant extended out past, out here, right? No, that's just the radius of the circle. The radius of the circle is 1. Unit circle means radius equals 1. So that length is just 1. The hypotenuse of that right triangle is 1. Does that make sense? Now I'm going to draw another right triangle. And I'm intentionally making it not the same size. But this angle here is still theta. Those two angles are the same. What does that tell us about this angle here and this angle here? They have to be the same as well. Because we have the right angles have to be the same. Theta is the same. If two of the angles in a pair of triangles are the same, the third one has to be the same. So that means that these are similar. And that's what trig is all about, is because these features form those right triangles within the circle, those right triangles are similar to every other right triangle that has that same angle. Now what we're going to do is we're going to look at the sides of this right triangle, and this of course is what side of the right triangle? It's called the hypotenuse. Now the other two sides are called legs, but we're going to have to give them special names. And the names for each legs depend on which angle we're looking at. If I were looking at this angle up here, the legs would switch places. Or at least the names would switch places. Looking at this angle, this leg here touches that angle. Call that the adjacent side. Adjacent means next to or touching. This side does not touch it. It's across from it or opposite it. Now let's look at our similar triangles. I'm going to look at sine. What side in the other triangle corresponds to the sine? The opposite side. I'm going to abbreviate it OPP. I also have the 1 side here. So let's look at the 1 here. I'm going to put that below the sine. What side in the other triangle corresponds to the 1? Hypotenuse. I'm going to abbreviate that HYP. So sine over 1 is just sine. The sine of an angle is equal to the length of the opposite side divided by the length of the hypotenuse. In any right triangle that has that angle in it, that ratio will be the same. Now let's look at cosine. We're going to abbreviate it COS. Cosine here corresponds to what side in the other triangle? Adjacent. I'm going to abbreviate it ADJ. Then I'm still going to use the 1 again. Well, the 1 still corresponds to hypotenuse. So the cosine is equivalent to the adjacent side. The length of the adjacent side divided by the length of the hypotenuse. Now we're going to go back up here again. And what I'm going to do this time, there's another right triangle formed. We looked at this right triangle here. There's another right triangle formed. This right triangle is this one out here, the bigger one. See where I'm getting at? It's this one here. I'm going to pull that one down here for a second. Well, this angle is still theta. Which side right now is equal to the radius of the circle? The bottom. This is the 1 unit. That's the radius of the circle. Because that came from here. This side over here is the tangent. And the hypotenuse is the secant. Remember the secant all the way up here? This is the adjacent. There's my 1 radius. So now looking at that triangle, I'm going to take the tangent. I'm going to abbreviate TAN. So tangent of theta over there. What side back in this triangle corresponds to the tangent? The opposite. Then I'm going to use the 1 again. What side over here corresponds to where that 1 is now? The adjacent side. The tangent of an angle is defined to be the length of the opposite side divided by the length of the adjacent side. And while we're at it, let's do secant. What side of the other triangle corresponds to the secant? Hypotenuse. HYP, we'll abbreviate it. We still got the 1. The 1 still corresponds to the adjacent side. So the secant of a triangle corresponds to the length of the hypotenuse divided by the length of the adjacent side. Now you can see these are using, these are not the definitions of those trig functions. We take those, and I even said definition. But that's not true. The definition of those trig functions are these links on the unit circle up here. Those are the definitions of it. But these ratios are equivalent to them. So the values of those trig functions are equal to these values of these ratios. Now there's 2 that I did not name yet, and I'm just going to give those to you. Cosecant is CSC, is the abbreviation. And that is equal to the length of the hypotenuse over the length of the opposite side. And then there's cotangent, which is equal to the length of the adjacent side divided by the length of the opposite side. Now, as you look at these, you will see that they appear to come in pairs. They don't just appear to, they do come in pairs. For example, tangent is opposite over adjacent. Cotangent is adjacent over opposite. They're reciprocals. You flip one over, you get the other. Cosine is adjacent over hypotenuse. Cosecant is hypotenuse over adjacent. Again, they're reciprocals. You flip one over, you've got the other. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Again, just flip it over. When we go to look at calculating these with the calculator, that's going to be kind of an important thing. Speaking of, let's talk about calculating these with a calculator. You have those 3 buttons on your calculator: sine, cosine, tangent, sin, cos, and tan. To find the sine of 60 degrees, on most of your calculators, you're going to hit the sine button, and then 60 degrees, and then equal. Some of you may have to type in the 60 first and then hit sine. You're going to get 0.866. Anybody not get 0.866? You're confused, Tate? No. Oh, gotcha. What if I ask you to do the cosine of 60 degrees? 0.5? Tangent of 60 degrees? 1.732 is correct. Now I'm going to pause there for now. Hands away from your calculators. Sine of 30 degrees. Now remember, we talked about co, meaning of the complement. What's the complement of 30? 60. So the cosine of 60, since 60 is the complement of 30, better equal the sine of 30, 0.5. Now punch it in your calculator. It is 0.5. Now again, hands away from the calculators. Can you tell me what the cosine of 30 should be? What's the complement of 30? 60, right? So the cosine of 30 should equal the sine of 60, which is 0.866. Give it a shot. Well, you don't have a cotangent key, so that's not going to work. We'll come back to that. The tangent of 30 degrees, 0.577. We're not to that yet, though. Any questions on finding those basic trig functions? Okay. So now here's the tricky part. Finding the secant of 60 degrees. Your calculator does not have a secant button. If we go back up here, however, we saw that secant was the reciprocal of cosine. Now, here's a spot where I recommend you make a page, like in the back of your notebook, or somewhere where you can flip to it really quickly. In fact, I would recommend having these 6 identities here written down on that page as well. So I'm going to pause right here and give you guys a chance to write that down. I'm even going to suggest you do this. Secant is equal to the reciprocal of cosine. Cosecant is equal to the reciprocal of sine. And erase that so it actually looks legible. Cotangent is equal to the reciprocal of tangent. And I would add that little piece to your list. And it is that little piece that is going to enable us to get back to what we were trying to calculate. So secant of 60 degrees. Secant is the reciprocal of what? Cosine. So we could do this. 1 divided by the cosine of 60 gives you 2, right? There's an easier way to do it. On most of your calculators, type in cosine, it'll give you that parentheses, right? Type in 60, close your parentheses. Now you don't hit equals, you have an x negative 1 key there. Then you hit equals. I'll give you 2. Richard, yours don't work that way. Yours, you have to do 60 cosine, then you've got a 1 over x key. Looks like this. So 60 cosine 1x, 1 over x. Did you guys get that to work out? Yeah, hit equals and see what happens. Give you 2? That's what you wanted. You give me 2? Yes, that's what you needed. You're good. So then cosecant of 60 degrees. Remember, cosecant is the reciprocal of sine. So we could, again, just do 1 divided by the sine of 60 degrees, which would give us 1.15, but that's no fun. So the easier way to do it on your calculator is hit the sine, parentheses opens up, type in the 60, close the parentheses like we did before, and hit the x negative 1 key. Gives you the 1.15 still. Right? Does it get to work? Good. Cotangent of 60 degrees. Again, you could do 1 divided by the tangent of 60. Gives you 0.577. Or again, the easier way is type tangent. Parentheses opens up, you type in 60, you close the parentheses, and then x negative 1. It's 0.577 again. The reason I'm saying this way is easier, it's really the same difficulty as doing this. But by doing it this way, it sets us up when next week comes around and we need to go back the other direction, do inverses. That's a different thing. Yep. That's the inverse sine rather than the reciprocal of sine. Yeah. That is something we shall talk about soon. So I want you to calculate on your calculator for me the secant of 30 degrees. What function on the calculator are you going to use? Cosine. Parentheses open up. What do you put in there? 30. Then what? Close parentheses. And then? X negative 1 gives you, you're right, 1.15. $1.15. Need a second to try it again, or?
I got it.
You got her? All right. Do cosecant of 30 degrees. What function are we going to use? Sine. 30, close the parentheses, x negative 1 gives us 2. Cotangent of 30 degrees. What function are you going to use? Tangent. Tangent. $30, close parentheses, x negative 1 gives you 1.732 is correct. Find for me the sine of 45 degrees. What'd you get? 0.707. 0.7071, right? cosine of 45 degrees? Same thing, isn't it? If you think about them, if it's a right triangle, if this is 45 degrees here, what's this angle have to be? 45 degrees. Which means this side and this side have to be the same. So the opposite side and the adjacent side have to be the same, right? So opposite over hypotenuse, adjacent over hypotenuse are going to be the same ratio. How's about cotangent of 45 degrees? Tell me what functions you're typing in. Tangent, 45, close parentheses, x negative 1, then enter. It's going to give you 1 either way. Both tangent and cotangent are equal to 1. Hold the sine of 10 degrees. Point 1736. Okay. How about the secant of 10 degrees? What function are you using? Cosine 10, close. X negative 1 gives you? What's that? 1.015 works for me. Tangent 10 degrees. 0.176. Cool. Cotangent of 10 degrees. Perfect. So the tangent, put the 10 in, close the parentheses, x negative 1, 5.671. No calculators. Cosine of 80 degrees. .10, 1.1736. Cosine of 80 has to be the same as the sine of 10. Cosecant of 80 degrees. Cosecant of 80 has to equal the secant of 10. Tangent of 80 degrees? Tangent has to equal the cotangent. If I'd asked you for the cotangent of 80, you'd have been right. But asked for the tangent. It has to go through the cotangent. So I give you a triangle, right triangle ABC. C is almost always a right angle. And let's say I tell you that this is 12 units long here. 35 there and 37 there. I ask you for the sine of angle B. Well, let's label some sides here. The 37 is what side of this triangle? Hypotenuse. I picked that one first because that's the only one that really has a name that doesn't change. Now I said angle B here, so let's look at angle B. I'm going to code this in blue for angle B. According to angle B, the 12 is which side? It's adjacent. It touches angle B. So that would be the adjacent side. Oops, let me put it up above it here. So the 35 has to be the opposite side. Now, if I were looking at angle A, which side would be adjacent? The 35, because that's the side that touches angle A. So, of course, the 12 would be opposite. It's like I said before, depending on which angle you look at, the opposite and adjacent sides flop, switch sides. So, for sine of angle B, sine involves what two sides? Opposite over hypotenuse. So what's the length of the opposite side according to angle B? 35. Of course, the hypotenuse is always the hypotenuse. That is 37. So the sine of B is 35 over 37. The cosine of angle A. Cosine involves what two sides? Adjacent and hypotenuse. According to angle A, which side is the adjacent? 35. And the hypotenuse is always 37. Now, I know I'm beating this one to death, but what's the relationship between angles A and B here? What do those two have to add up to? 90, because the triangle is 180. If this is 90, that leaves 90 left for those other two to add up. So A and B are complements. What do we notice about the sine of B and the cosine of A? Because the cosine is the sine of the complement. Since B is the complement of A, the cosine of A is the same as the sine of B. So it's the sine of A. Sine is opposite over hypotenuse again. So according to angle A, what's the opposite side? 12. The hypotenuse? Always 37. Cosine of B? Cosine's adjacent over hypotenuse. What are those two sides going to be? 12 over 37. Again, notice. A and B are complements. Sine of A is 12 over 37. So the cosine of B, which is the complement of A, is 12 over 37. If they're complements, the cosine of one is equal to the sine of the other. Have I beat that one to death enough yet that we can let her go? The cofunction is always the function of the complement? For now? We'll come back and pound on it again next week. By Tuesday, well, actually it'll be by Thursday. I won't see you on Tuesday because remember I'm in interviews. By Thursday it might fade a bit.
Yes.
How about tangent of angle B? I'm actually going to do a double lecture today. I'm going to lecture right up till almost time to go. So you guys have to make up for missing Tuesday. Tangent of B. Tangent is what sides? Opposite and adjacent. So according to angle B, what's the opposite side? 35. What's the adjacent side? 12. Come on. Secant of angle A. What's secant? What sides? Hypotenuse and adjacent. Reciprocal of the cosine, right? Just flip that over. Right? Hypotenuse is 37. According to side or angle A, the adjacent is 35. Again, that's the reciprocal of the cosine of A. Cosecant of angle B. Cosecant involves what two sides? Hypotenuse and opposite. Again, the reciprocal of the sine. Sine's opposite over hypotenuse. Cosecant is hypotenuse over opposite. According to, well, what is the hypotenuse? 37. It doesn't matter which angle for that. According to angle B that we're looking at, what is the opposite? 35. Again, 37 over 35, 37 over 35. A and B are complements. So the cosecant of B equals the secant of A. Okay. What if we want to go the other direction? What if I know the sine and I want to find the angle? For example, let's say I tell you the sine of angle A is 0.615. This is actually an equation. Just like sine of x, you could say, is equal to 0.615. Remember, when we were first learning how to solve equations, we talked about inverse. If x plus 3 equals whatever, how did we solve it? Subtracted 3, right? Adding and subtracting are inverses. If you added 3, if you subtract 3, it takes it away. It reverses it. It undoes it. Or if I had 5 times x equals something, how did I get rid of the 5? Divide. If x is multiplied by 5, dividing by 5 reverses it. Multiplication and division are inverses. They reverse each other. If I had x to the third equals 27, how did I solve it? A cubed root. A power and a root reverse each other. They're inverses. If we got into like decibels and power calculations like telecom did, you'd even see logarithms and exponentials. Well, trig functions have inverses as well. So to solve this equation, we have to do the inverse. What's being done to my variable? A is the variable here. Think of A as being x. What's being done to it is we're taking the sine of it. You calculate as that button with the little sine -1. That is the inverse sine. And we have to do it to both sides. So on the left over here, sine, inverse sine and sine cancel out, leaving it with just A. On your calculator, you get secant sine 0.615. Which 37.951 degrees. Now there are several ways you will see that written. You'll see me write it sine -1 is the way I almost always write it. But it can be written like that, inverse sine. And a kind of archaic notation, arc sine. That means the same thing. Inverse sine is all it's saying. What it's asking is what's the length of the arc that corresponds to that sine. Remember, the arc would be, technically arc sine is asking for the angle in radians, but we're not gonna make you do that. You can just give me the angle in degrees if you get an arc, if you're asked for arc sine. So if I tell you that the cosine of angle B is equal to 0.208, to solve that, we're going to do inverse cosine. So again, the inverse cosine and the cosine cancel out, giving me just b. If you do secant cosine, 0.208, it gives you 77.994 degrees. If I tell you that the tangent of angle D equals 3.156, how am I going to find angle D? So the inverse tangent. Again, tangent and inverse tangent cancel out. D equals secant tangent 3.156. It should work still. 72.418 sounds correct to me. Any questions there? You like it? Oh, that's good so far.
Resembles things that I kind of know.
If I tell you the sine of f, 1.083. Oh no.
What happened there?
It says error, doesn't it?
Yes, it does.
Let's go back to our unit circle here. And explore. The sine, remember, is the distance from any point on the circle to that reference diameter, right? First of all, what's the radius of the circle? What's the distance from here to here? 1. It's a unit circle, so it's 1, right? So we start down here where the sine's really small, and as we move up, the sine gets bigger and bigger, right? Until we get to here where the sine's at its largest. What is that value? 1. As I keep going, though, the sine starts to get smaller. The sine can never be larger than 1. Or, as I go this way, of course, the sine is negative because it's below the line. The smallest it can be is here where it would be negative 1. So the sine is always between negative 1 and positive 1. Now, let's take a peek at secant. Remember how the secant was formed? Let's say this is our angle here. The secant has to contain points both inside and outside the circle, right? Well, to get outside the circle, what's this distance from center to there? 1. So to get outside the circle, it has to be greater than 1. The secant of an angle is always greater than 1 or less than negative 1. Now, because of the relationship between sine and cosine, it implies that cosine has the same relationship as sine does. Cosine is just going side to side instead of up and down. Cosine is always going to be between negative 1 and positive 1. Cosecant is always either greater than 1 or less than negative 1. Now, technically, I probably should have put greater than or equal to, less than or equal to, because it is possible for one of these functions to equal exactly negative 1 or exactly positive 1. Type in the sine of 90 degrees. What do you get? 1. If I tell you that the tangent of angle G equals 3.84, that tells us that G is, what's that? Do you guys concur? 403? So it's just secant tangent 3.84. 75.403 degrees. How about if I tell you the tangent of H equals 0.032? $17.744. So you can see tangent has no restrictions. Tangent can be anything. It can be smaller than 1. It can be bigger than 1. Because of the nature of the tangent, it does not have restrictions. Let me try that again. I'll punch it in. Secant tangent 0.032. You missed the 0. Yeah, it's 0.000. Try that again. Secant tangent 0.032. 1.83 degrees. That's right. 1.83 is better. Okay. You guys should know better than to trust Tate. What if I tell you that the secant of A equals 2.65? Now remember, when we calculated a secant, what keystrokes did we do? We did cosine, put in the angle, closed the parentheses, and did that x negative 1, right? So to do an inverse secant, I mean, obviously there's no secant button, so there's definitely no secant inverse button. To do an inverse secant, you press in the secant, then the cosine, negative 1. You're going to type in the 2.65, but you're not going to close the parentheses yet. You're going to put the x negative 1, then close the parentheses. $67.83 degrees. Your calculator, you put in the 2.65, 1 over x, then secant cosine. Cosecant of B equals 1.93. So we've got to do an inverse cosecant. Again, no cosecant button. So we're going to use the secant inverse sine. 1.93. Do we close the parentheses? No, we do what first? X negative 1. Then we close the parentheses. That sounds promising. 31.207, you got it. How about cotangent of angle D is 0.8. We're doing an inverse cotangent, which is going to involve us to do what? Second inverse tangent, 0.8. The x negative 1 in there. Close equals 51.34. Finally, well, if I tell you the tangent of angle F 3.14. You just do second tangent, type in the 3.14, close the parentheses and go. This tangent is one of your functions, right? So to do an inverse tangent, you don't have anything special. In ye old big book, page 691, it's exercise 33-3. Page 693, exercise 33-5A. Page 694, exercise 33-5B. Page 696, exercise 33-5C. And also on page 696, exercise 33-5D. Those will keep you busy, give you something to do on Tuesday when I'm not going to be here for class. Didn't want you guys to get bored.
We appreciate that.
Oh, yeah, of course. I will let you guys have the last 14 minutes to get started on that.